Is the following statement true, that for all integers a, b, and c, if a divides b and a divides c, then a divides the difference between b and c? Well, let's think of some examples. And before I do that, if you watched the video where we looked at a divides b plus c, you would have seen that we proved that this was true. And in reality, this statement is the exact same as that statement. But what's the only difference is that this negative is basically like saying b plus negative c. So because we proved already that the sum of b plus c for all b and c is going to be divisible by a given those same conditions, well, if c is negative, negative c is still a part of all c. So this statement should automatically be true. But let's say you didn't watch that video. So let's go ahead and try and look at some examples and prove it as if you've never seen that proof before. Well, let's start by having a be equal to, let's say, 2. And let's take our b and c to be equal to 4, and let's take 8. Now, what does divisibility mean, or what does it mean for 2 to divide 4? It means 4 is a multiple of 2. This means 8 is a multiple of 2. What does it mean for them to be multiples of 2? Well, it basically means that 4 can be written as 2 times something, and 8 can be written as 2 times something. That something that 2 has to be multiplied by must be an integer. So in this case, k is equal to 2. In this case, m is equal to 4. 2 and 4 are both integers, so it's true that 2 divides 4 and 2 divides 8. So that's the logic behind choosing these numbers. So let's have a look at whether or not it's true that the difference between 4 and 8 is divisible by 2. So we can then ask ourselves, well, does 2 divide 4 minus 8? And the answer is probably. How do I know this? Well, when we're taking divisibility, we want to get it so what's over here, what's on the right-hand side of this line, can be written as what's on the left-hand side multiplied by some integer, right? That's what we're going to try and get. As I've shown with, for example, 8 can be written as 2 times 4, so this means this is the same as asking, is 2 divisible by 2 times 4? And because 2 is on both sides, this statement is true. So that's the logic we're going to use here. So we're basically asking, let's factor out a 2. Let's see if that's true, right? This is the same as asking 2 divides 2 multiplied by 2 minus 4. And because we got what's on the right, on the left-hand side, multiplied by some sort of integer, 2 minus 4 is going to give you an integer of negative 2. This statement is true. Now, if you want to be super explicit, if you still don't see why this is true, let's just forget about this step here and just say, okay, well, this is like saying 4 minus 8, that's negative 4. Does 2 divide negative 4? Well, can negative 4 be written as 2 times some integer k? Well, let's rearrange for k, right? We can say negative 4 divided by 2 is going to equal to k, which is equal to negative 2, and negative 2 is in fact an integer. And what you should notice is this should be equal to what we have here, 2 minus 4. Now let's take a look at, let's say maybe 3, or no, let's take 5. Or no, let's do 4. Yeah, I've decided we'll do 4. 4 and let's do 12 and 4 and 16. Or let's switch these around. Since we got negative numbers down here, let's get some positive numbers over here. Okay, 4 divides 16, 4 divides 12. This is true because 16 can be written as a multiple of 4. So 16 is basically saying 4 times 4. And 12 can be written as a multiple of 4 because 12 is the same as saying 4 times 3. So is it true that 4 divides 16 minus 12? Well, can we factor a 4 out on the right-hand side? The answer is yes. So this is the same as saying 4 divides 4 multiplied by 4 minus 3. So there we go. We've shown that it does in fact do this. Again, if you're still struggling with seeing this, just go through the math here. This is the same as saying 4 divides 16 minus 12 is 4. And 4 does in fact divide itself because 4 can be written as 4 times 1, where 1 is an integer. There we go. And what you should notice, this thing we're multiplying, our left-hand side by to get the thing on the right-hand side should be equal to what we have here in the brackets, like we had over there. So it's looking like this statement is most likely true, so let's go ahead and try and prove that. So before we prove this, we of course need to clearly define what we mean by divisibility. We've already seen kind of what it means. We're basically saying B is a multiple of A, but let's put that in a mathematical definition. So we define divisibility as for some integers A and B, where A divides B and A cannot be 0. People oftentimes, including me, forget about this condition. Why is this true? Once again, this is true because if A was equal to 0 and we ask, well, does 0 divide any integer B? You're basically saying, can B be written as 0 times some integer k? And the answer is no. And why is that? Because if we know k has to be an integer and we want to find it like we did in our examples, we have to rearrange for k, and what we do is we then say b divided by 0 is equal to k. But you can't divide an integer by 0. That's an undefined term. This is not possible, which means that because this is not possible, k cannot possibly be an integer. So that's why we have to say that what's on the left-hand side cannot equal to 0, because then you end up in a case like this where you're dividing by 0. So now that we've said this, we can then say then, or let's write that down here actually, then b is equal to a times k for some integer k. There we go. That is going to be the definition we're going to try and use to prove that the statement that a divides the difference between b and c is in fact true. So this is a for all statement, which means that we obviously always start with a let. You can start with a suppose, but I like to do let for all statements. So we say, oh, maybe I need to get a different marker. There we go, I think that's better. So we say let a, b, and c be integers where a divides b and a divides c, and a, of course, is not equal to 0. We're basically copying our definition and applying it to our p statement over here. Next, we want to unpack what it means for a to divide b and a to divide c, because we can't use this in math. We have to put these in formulas, some kind of an equal sign or an inequality. So we then say, then b is equal to a times, let's use, what letter do I want to use? Let's use z, and c is equal to a times, not z, let's use y, where z and y, or my bad, z comma y are integers. Fantastic. Now that we've defined everything, we can now maybe have a look at what we have here on the right and ask ourselves, can it be written as a multiple of what's on the left, in this case a, which means can we get this to look like a times something in brackets, and this in brackets must of course be an integer. So let's give that a shot. We can say, next, b minus c is the same as saying a z minus a y. What do we notice? We can factor out an a here, which is going to be the same as saying a multiplied by z minus y. And there we go. We've done what we've been looking to do. Get it to be multiplied by something on the left-hand side, multiplied by an integer. So we just have to explicitly tell the reader that z minus y is an integer, and this should be pretty obvious because an integer subtracted from another integer is still going to give you an integer. So we say where z minus y is an integer. Now you can definitely just conclude that a divides b minus c, but I want to be really, really explicit why. So we're going to say in conclusion, a divides b minus c because b minus c is equal to a times z minus y. So b minus c is a multiple of a. There we go. We've now proven that it is in fact true that for all integers a, b, and c, if a divides b and a divides c, then A divides the difference between B and C.